Hi, today we want to learn the deforestation mapping with the Landsat satellite. Deforestation is one of the most pressing environmental issues of our time, particularly in a region such as the Amazon rainforest, and which serve as a critical carbon sink, helping to mitigate the effect of climate change. And monitoring deforestation over time is crucial for sustainable land management and conservation effort, and remote sensing such as a satellite imagery provide a powerful tool for tracking trends in the forest cover, detecting illegal logging, and understanding environmental impact on the ecosystem. In this tutorial, we use a Google Earth engine to detect the deforestation using Sentinel-2 imagery and the normalized different vegetation index NDVI used. NDVI is widely used for vegetation index to help to distinguish healthy vegetation from non-vegetated surface by analyzing the different NDVI values before and after a specific event. We can identify areas where deforestation has occurred. This script demonstrates how to use Sentinel-2 satellite imagery to detect the deforestation in a specific area of interest and with a certain time range using the NDVI, and we compare NDVI of two different periods before and after deforestation, and we focus on identify area with NDVI has a significantly dropped and indicating potential deforestation. First, we need to define the area of interest with a bounding box. If you don't know how can use the bounding box, you can watch video related this. We selected the Amazon rainforest, and if we run this, we zoom at these areas, and area of interest is a geographic region that you are interested in here defined by the rectangle that cover part of Amazon rainforest, and map.center object center the map view on the area of interest, and we need to define the date before and after image. In this case, we compare time period of June 2020 until September 2020 before deforestation, and June 2023 and September 2023 after deforestation. And after this step, we load the load and process Sentinel-2 image. We load Sentinel-2 image from a Google Earth engine. We use the COPERNICUS S2 as our harmonized dataset, which provides surface reflectance data for Sentinel-2. And if you want to know what is dataset, you can watch video about the Sentinel-2 true color videos. And we filter image by the date, area of interest, and cloud coverage, keeping only the image with less than a 5% cloud coverage. And we filter the bonds, filter the image to include only the area of interest, filter the date, filter the image to include only those from the defined data range, and filter the cloudy pixel with the 5%, and the median, take the median pixel values for the selected time period, reducing the cloud impact and enhancing the image quality. And step 4, get before and after uh, composite with this function. We define the before start and before end, and after start and after end. And after this step, we calculate the NDVI. NDVI is to monitor vegetation health, important for monitoring vegetation health, and value uh, range from -1 to 1. The healthy vegetation generally has a value closer to 1, and non-vegetated area like water or barren land have values closer to the 0 or negative. And we need to write the function for calc NDVI and return the image normalized difference. We use the bond A near infrared bond and bond for red bond are used for NDVI calculation, and normalized difference compute NDVI using the near infrared subtract red, divide near infrared plus red, and compute the NDVI difference with this subtract NDVI before, and rename it to NDVI difference. They subtract the calculate the difference in the NDVI between the two time period, and we name the NDVI diff, and we need to after this deforestation masks, and we create the binary mask where the drop in NDVI greater than zero point 0.3 is considered a deforestation. This threshold is based on a typical NDVI change and seen in the deforestation event. And the mask is created for area where the NDVI difference is less than a minus 0.3, indicating the significant to the vegetation. And after this, we can visualize the map. We use the true color for compare B4, 3, and 2 with minimum 0 to maximum 1000. The bond 4 is a red, green is a 3, and bond 2 is blue. And NDVI difference visualization with a red to green color to highlight the area of a deforestation. And after this, we can add the layers on the map, the two color image before and after, and deforestation with using of a masks. If we run this code, you can see the two color before and two color after. We have some changes in all area. You can see with the detected deforestation. Here we have some submerged forest here detected with this algorithm and detected deforestation here. We can zoom and compare with the true color for validation. Here we have the any deforestation. We can, yeah, as you can see, yeah, the algorithm captured this deforestation. If you're interested in deforestation mapping, you can watch video about the deforestation mapping of Sentinel, mapping of a Landsat. This one is for Sentinel 2. You can watch the Landsat one and compare the results together. Thank you for your watching. Please like and subscribe our channel.